Hi guys, so in this video I am going to solve another interesting question, that is LRU cache. Okay, so what's the meaning of LRU? LRU is basically least recently used. Okay, suppose if you are having a stack, then in stack it's clear that you are using the topmost element, latest, and removing the topmost element from the stack. Okay, so similarly q you have FIFO. So similarly we are having LRU least recently used. So let's see how to implement this question. Okay, so first of all, see, let's how to approach this question. Since you are given to implement the complete class of this, so here you have given some function LRU cache int capacity get key void. Okay, can you get put in order of one time complexity? Okay, we will try to see what how to get and put in do this function in order of one time complexity. Okay, first let's see what is LRU. Okay, so 1, 2, 3, 4. Suppose I am having a capacity of size 4. Okay, and I am having element 1, 2, 3, 4. So this is basically a cache. Okay, cache memory or something you have already learned or studied in OS operating system. So if you not, if you are in first year, second year, then you are going to learn in that also. So okay, so don't worry about that. I'm just going through the approach that I'm going to implement in this question. Okay, so you are having 1, 2, 3, 4. So if you are going to use 2, okay, since 2 is in our cache memory, okay, so it will delete from here and it will put it here. So means 2 is the recently used item and 4 is the least used item. Okay, least means at the end the thing which is at the end is not used frequently. Okay, so least recently used. Okay, so we have to implement something like this. Okay, if suppose if our size will be 5 and we are going to add something to our LRU cache, then it will be 5. No, not write this, means you can't add anything to 5 at the end, you have to write here. Okay, so this will be your data structure. Okay, so you have to choose some data structure in which you have to put anything at the start, or you can have to remove anything from the middle in order of one time. So the best data structure that I have learned till far is linked list. Okay, in linked list you can add anything at the starting point, but you can't get anything in the middle in order of one time complexity. Okay, so we are going to use doubly linked list. In doubly linked list you have the two pointers that will be next and previous, which will give you the this get function in order of one time. Okay, so get function in order of one time, but still get function can't be done only using the um, doubly linked list, because if you are removing something from here, we have to keep track of that, means what we are using and what is the size of our cache memory. Okay, what is the means you have to maintain something that will store the size of your cache memory. So suppose if my cache memory is full, suppose if I am going, suppose my cache capacity is 5 and I am going to add one more here, it won't add, so we have to add something here. Okay, and 5 will come here and the last one will be deleted. Okay, 65213. So you have to make something like this. So for this, since we have already learned only one thing, that will hold key pair value and that will hash map. So I'm going to implement this question using doubly linked list and hash map. Okay, so let's see how to start the question. Okay, so first define a class, since there are two values given, int key int value. Okay, and there is two pointers, not previous, node previous and node next. Okay, and here let's do something, declare at the top of the function, so that we have to use these things, continuous repetitive statements in our methods also. Okay, so node head. Okay, so what is this head and tail? Okay, let's wait for some minute. I will explain you why I am written head and tail at the top. Okay, and map will be there. Int node map and int. Let's define one more thing. Int size of our capacity. Okay, so these two are basically my dummy head and tail. Basically, suppose head will be here pointing to this. Okay, and tail will be there at the end to pointing to this. Okay, so you can understand that my cache size will be in between the head and tail, so this will make us easy to travel from head to tail. That's why I am using two dummy head. Okay, and this capacity I am using because I have to use this capacity in all our methods. Means if it's required somewhere else in our method to check whether our capacity is full or not, that's why I am using here cache capacity. Okay, so first define head, next equal to tail. So I am just initializing the value, nothing else, equal to head. Okay, and my map function will be map equal to new hash map, and the capacity will be capacity. Okay, and this dot cache capacity means capacity of my uh, cache will be capacity. Okay, so these two functions are done. Now I'm going to create two more functions that will make it easy for me. First one will be to add anything to our linked list or add any node to our linked list, and second one will be remove any node to from our linked list. Okay, so let's create two more method. Public void add. So you are going to add something at the in the linked list, doubly linked list. So as the in example we have seen that we can add anything to our cache uh, only at the front of that LRU cache. So I am going to implement that part, means we are only adding something to our head. Okay, after head we can't add anywhere else. We have to add anything at that okay, anything after head. So head next will be head dot next. Similarly, node dot next equal to head next. Okay, node dot previous equal to head. Okay, and head next dot previous equal to node. It's easy. I think it will be easy to understand what I am doing here. Just manipulating the previous and next node and adding a node in between to them. It's dummy node. Between dummy and first node I am adding a node, and the dummy node is head, and head next will be the first node, and inserting one value in between them. Okay, so you can see how easy it is if I am creating two dummy nodes here. Okay, so let's see one more method I have to do, means for deletion purpose. Public void remove node. Okay, So if you are going to remove this node, what you are going to do? Basically, just manipulating means just you have to store two nodes. That will be node previous equal to node top prev. Okay, node next equal to node dot next, and node next. Okay, dot prev equal to prev node prev. Okay, and node prev dot next equal to node next. Okay, so just manipulating the things in a way so that we can remove the node. Okay, so basically the two pointers are pointing to each other and connecting node next to the node previous. Similarly, this put to part is done. Now you are have to put. Okay, first let's see how to. Okay, first I will put, then I will get. Okay, then how to do this part? Public void put int key value. So we have to first check whether our value is present in our map or not. Map dot get key. Okay, not equal to null. If not equal to null, then if map dot get key is not equal to null, then what we are supposed to do means our key is present there. Okay, key is present in our LRU cache. Then we are going to just removing that node. Okay, just store it somewhere. Node equal to map dot get. Store it somewhere and remove this node. Okay, remove this node and update the value of node to value and add this node. Why I am removing and adding this node? Because I have already told you, if something is in between this, okay, if something is between this, if one is there, so I have to remove from here and add it to the front of the linked list according to LRU. Means the data structure, the way the data structure is operating, we have to think like this. That's why I am using hash map and doubly linked list. Okay, so this will add the value to the node, and I am updating the value also. Else I will check the capacity of my map. If my map is equal to cache capacity, that's why I have used this variable, because I need this variable somewhere in between. Okay, if something like that, then what am I supposed to do? Just see. If my map size is equal to cache capacity, then which node you can remove? You can only remove this part, because this is the least recently used item in your data structure or cache memory. Okay, so you have to remove this only. Okay, so let's see how to remove this. So I'm going to remove map dot remove. Okay, this is the inbuilt function to remove something from map. Tell dot prev dot key, and this is my function to remove from linked list. Remove. Okay, tell dot prev. Okay, why I am writing node. Okay, so this will remove my value. Now create a new node, because our node is not present there. Okay, so my node is not present there. I'm creating a new node. So node dot key equal to key. Similarly, node dot val equal to value. Now I have to add this node to our doubly linked list and put this to our hash map. Okay. Similarly here, public int get int key. So if, okay, first of all I have to check. Here written something like this. Okay, read it first. Int get int key, return the value if the key exists, otherwise return -1. Okay, so let's check whether my node is existing or not. If my node will not exist, then I will return -1. Okay, so first declare a variable for returning. Okay, if node not equal to null. If node is not equal to null, then I have to remove it from uh, doubly linked list and update the value of node to, okay, I have to update the value of result equal to node dot val and add it to top, means add it to the front of doubly linked list and return result. Let's check whether it's working or not. Line 65 class. Okay, class. What type of class? I didn't mention here. Class node. Okay, it's showing some error. Let me check. Okay, here's something too, and I have to means I have to see where the error. So guys, here's the problem. Why it's causing error because of I haven't written head.next equal to node, means dummy node. I have to point it to the node. So after that, it's working properly. So let's check. Okay, it's working properly. So I hope this is one of the interesting question. And if you have any question in your mind or want me to uh, solve your question, then join the Telegram channel. Link in the description, or you can ask me in comments. Let's see whether it's running or not. Okay, okay, it's running properly. So thank you so much, guys, for watching, and